Welcome back. In this episode, we're looking at bars and stars. This gives us a technique for answering more counting questions. So let's start with an example. You are constructing an orchestra with 8 students. Okay, it's not a very big orchestra. You have to sort them into a string section, woodwinds, brass, and percussion. And some sections can be empty. Yeah, this is not a very good orchestra, but let's roll with it. And we see that 2 orchestras are the same if the number of students in each of their sections is equal. Okay, so that's the defining characteristic of these orchestras. Show that there are 165 different orchestras that you can make. So, for example, an orchestra here would be, 2 string, for example, 3 woodwind, let's say 1 brass, and 2 percussion, right? So this is an example of an orchestra. So, you can try listing all of these out. There's going to be 165 of them, but how might we figure that out? Okay, well, we're going to use a technique called bars and stars. So this is the idea. So I'm going to think of each person here as being this star. It's going to be a person in our orchestra. Okay. I'm going to think about putting these bars to separate the different sections. Say this section over here will be string. Put another bar here to separate it. This section will be woodwind. Another bar. This section is brass. And the remaining section here will be the percussion. And then this orchestra that we've made up here, well, we have 2 strings, 3 woodwinds, we have 1 brass, and we have 2 percussion. Okay. But then this is essentially how we can make any such orchestra, right? So we can also do, for example, 1 string, nothing in woodwind, 5 brass, let's say, right? And then 2 percussion, right? So this is another perfectly valid thing we can do. And so really, the number of orchestras is the number of arrangements we can make of these. So essentially, it's the number of ways to arrange. Well, we have 8 stars for the 8 people, and 3 bars, right? Because each of the bars separates the sections. So what is the number of ways to do this? Well, this is essentially the number of ways to choose 8 slots, let's say, of 11 slots for the stars, right? Because you can imagine, let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and you're just choosing, let's say I want stars here, 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 and 1, 2, 3, 4, 5, 6, 7, 8, right? And the remaining ones will just be the bars, right? For this is number of ways to choose 8 things from 11 things. So this is just 11 choose 8, right? And of course, this is equivalent to 11 choose 3. So maybe I'll just write that here off to the side. This equals 11 choose 3 by our formula, but also just by the fact that choosing 8 slots to be stars is the same as choosing 3 slots to be bars, right? So it's however way you like. Again, they're equal. What is 11 choose 8? Well, we can use the factorial formula or use a calculator, whatever you like. I'm going to use my calculator right here. 11 choose 8 is 165, as we expect. So we can generalize this technique, and this is what's called bars and stars, right? And it's this: the number of ways to sort k identical objects. So in our last example, these identical objects were students, into n distinct bins. So here the bins were sections of the orchestra, right? And it's n minus 1 plus k choose k. And the proof is basically as before, right? So the number of ways, let's write it like this, the number of ways is the number of arrangements, I'll say it like this, of k stars and n minus 1 bars, right? Because, we just have some stars, some bars. This is us sorting things into bins, basically, right? You can imagine that this here is bin number 1. This here is number 2, 3, 4, 5, right? And we're sorting 6 stars, right? So this is an example of how we do this, right? But then what is the number of arrangements of k stars and n minus 1 bars? Well, we're choosing, essentially, I'll just write it down, but maybe I'll explain in a second why this is true. Because it's n minus 1 plus k choose k, because we're just choosing k slots to be stars from n minus 1 plus k total slots, right? Because we have n minus 1 bars and k stars. Okay, so nothing much really to say here. I think the previous example is pretty much the proof of this, if you'd like. All right. So this is a very useful technique for these kind of problems when it comes to arrangements of things. And there's a pretty cool application of this, which I'll show you next. Show that there are 6 non-negative integer solutions to x1 plus x2 plus x3 equals 2. So what do I mean by a non-negative integer solution? I just mean, for example, we could take x1 equals 1, x2 equals 1, x3 equals 0. Okay, so this is a nice non-negative integer solution to this equation, right? Something like x1 equals minus 1, x2 equals 3, x3 equals 0. This isn't good, right? So there are 6 such non-negative integer solutions. Well, you can just count them. That wouldn't be too hard to do. But there's a bit more of a general way to do this. And it's with bars and stars, right? You can imagine here, we set up our bars, where this first part will be for x1, this part will be for x2, and this part will be for x3. And our stars are essentially integers. So if I want to take this solution and I want to put it into bars and stars form, essentially, just put 1 star with x1, 1 star with x2, and nothing in x3, right? Okay. And so what do we have then? We have 2 bars and 2 stars, right? So what is the number of solutions then? The number of solutions is just 2 plus 2 choose 2, right? It's the number of bars plus the number of stars. Choose the number of bars, or equivalently, choose the number of stars, which equals 4 choose 2, which is 6, right? We've done the 4 choose 2 example before, but again, you can use a calculator, use the formula, use whatever you like. And of course, we can make this more general. What is the number of non-negative integer solutions to this general equation? x1 up to xn equals k. And I claim it's just the bars and stars formula, right? Because, again, we can just make our little bins here. I guess I'm doing it from above this time. We'll say that x1 is this part, right? x2 is this part, so on, up to xn, which is the last part. Okay. And, we fill in stars as we go. Doesn't really matter. The point is that we have n minus 1 bars, right? Because we have n bins. And we have k stars, where each star is essentially 1, right? Each star is 1, because we have k stars, and we want them to sum up to k. Okay, so then the number of solutions, just by bars and stars, right? This is just n minus 1 plus k, choose k, which is what we want. Okay, so this is a very useful technique for these kinds of problems. And that's it. Not too bad. All right, thank you for watching. I'll see you in the next part.